The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of Odd Digit Numbers Reducing the Groups. Example, 15,129. In the examples that we used in the previous sections using 5-digit numbers, we made the numbers into 3 groups, each group having 2 digits except one group which has 1 digit. For calculating the square root, we took the groups separately. Such a procedure is useful when we are dealing with the higher numbers. For example, when we find out the square root of 82,146, we normally consider the groups as 8, 21 and 46. But it is quite acceptable to take 8, 21 and 46 as the 2 groups. The only problem may be to find out the perfect double-digit square roots in 821, and therefore we start treating this as 8 and 21, that is 8 as the first group and proceed with the subsequent groups. However, in the case of numbers having smaller digits, it may be easy to reduce the groupings into 2 instead of 3. We have been highlighting that knowledge in multiplication tables up to 20 may be beneficial for calculation, and such multiplications are always easy to recall. In the example 15,129, when we take the first 3 digits 151, we know that 144 is the highest square, as 12 multiplied by 12 is 144. Therefore, instead of considering the number as 2 groups, that is 1 and 51, we can straight away take 151 as a single group and proceed with the square root calculation, and we will get the same result. Let us demonstrate this. Take the number 15,129 and consider 151 as the first group and 29 as the second group. Let us set the number 15,129 by leaving 3 columns in the right extreme of the abacus. That is, the lowest digit 9 of the number should be set in the thousands column, 2 in the 10,000s column, and the remaining numbers in the columns left to each number. Now we have set 15,129 in the abacus. Take the first group 151 and consider the highest perfect square there, which is 144. Take the square root of 144, which is 12. Set the 12 by skipping a column to the left of 1. So 12 into 12, that is 144, that should be subtracted from 151, and we get the remainder as 729. In the next stage, we have to double the number 12 and set the 24 in the extreme left of the abacus. Consider 2 the highest digit of the number on the left end and 7 the highest digit of the remainder. Ask how many 2's in 7. You get the answer as 3. In the case of small numbers, you need not have an assumed quotient. Therefore, straight away set the number 3 to the right of the first two digits of the square root 12 and to the right of the number 24, which is set in the extreme left of the abacus. Now multiply 3 with 243 and the value should be subtracted from 729. That is 3 multiplied with 2, which is 6, and this is subtracted from 7 and the remainder is 129. In the next stage, we have to multiply 3 with 4, which is 12. That should be subtracted from the higher digits 12, leaving the remainder at this stage as 9. Let us multiply 3 with 3, which is 9. That should be subtracted from the number 9. There is no remainder. Therefore, the square root of 15,129 is 123. The problem clearly demonstrates that having knowledge of the multiplication tables, at least up to 20, will help the child in cutting down the steps in doing problems in multiplication, division, square root, etc. And therefore, there must be efforts to improve the knowledge in multiplication tables. In case the child is not familiar with multiplication tables, smaller groupings of numbers may always be considered in square root problems, which may take slightly a longer time for calculation, but definitely gives the desired result.